Got a harder example involving probability here, which will lead us down quite a lot of mathematical paths, including solving a quadratic equation. Probably a little bit surprising from a probability example, but so have a look at this one and see how you get on. Okay, so we've got a bag of green and blue balls. We're told that there are 3 more blue balls than green ones, and the number of green balls is greater than 4. 2 balls are selected at random, and from that we understand that the 2 balls are selected and none of them are replaced. And then it says the probability of selecting balls of the same colour is 22 divided by 55. Find the number of green balls. So if we're going to draw a probability tree, we're only interested in the 2 branches that result in either 2 greens or 2 blues. So first of all, how do we deal with the fact that we don't know the number of balls in the bag other than that there are 3 more blue balls than green ones? And with any example like this, if you don't know a quantity, give it a letter. I'm going to say that the number of green balls is x, and therefore the number of blue balls is x plus 3. And that means the total number of balls in the bag is 2x plus 3. So what's the probability of choosing a green ball? Well, we've got x green balls in the bag, and we've got a total of 2x plus 3 balls to choose from. So the probability of reaching this first ball is x over 2x plus 3. That ball is not replaced, so when we choose the second green ball, not only has the number of green balls gone down by 1, the total has gone down by 1. So the probability of choosing that second green ball will be x minus 1 over 2x. 1 down, remember, so this is plus 2. Let's do the same for the blue balls. The probability of choosing that first blue ball will be x plus 3, the number of blue balls available, over the total, which is 2x plus 3. Again, when we choose that second blue ball, the first blue ball's not been replaced, so our total number of blue balls and the total number of balls in the bag have gone down each by 1. And this will work in exactly the same way as we did for the green balls. We get x plus 2 over 2x plus 2. So now we've got to work out the combined probability of getting 2 green balls. And this will be the multiplication of getting to the first green ball multiplied by the probability of getting to the second green ball. In a similar way, to arrive at the blue destination of 2 blue balls, the probability here is the multiplication again of the individual probabilities. So we get x plus 3 over 2x plus 3 multiplied by x plus 2 over 2x plus 2. Now, the probability that we select 2 balls of the same colour is given in the question as 22 over 55. Well, what does this represent? Well, this represents the fact that we don't really care whether they're green-green or blue-blue, but they have to be the same colour. And we reflect that mathematically by adding the green-green probability added to the blue-blue probability. So let me write that out. And that must be equal to 27 over 55. Now, at this point, you might say this is getting really nasty and I must have made a mistake, but you haven't. It is just nasty. So we've got to try to solve this in the easiest way possible. The one thing to note, of course, is that the denominators, here and here, are both the same. So we can simply just add the top line and put them over a common denominator. And there we have it. Still looks quite gruesome. The next job to do is to multiply the top line out and combine and simplify it. And that simplifies to this. All I've done is I've combined the x squareds and the x's on the top line, and we've got 2 quadratics above each other equaling 27 over 55. Now, hopefully you can notice over here we have a common factor of 2. There's 2, 2, 2, all within those terms and equally on the bottom line. So I can cancel the 2 out of everything on the left-hand side. So coming up here, I get. Cancelling that 2 has brought these numbers, all of them down, which will make our multiplication that we need to do by 55 and 27 much more easy. Well, we've now got to cross-multiply. So the 55 will multiply all these three terms, and the 27, when it cross multiplies up, will multiply these three terms. So we get. Now we need to move everything onto the left-hand side and make the quadratic equal naught. Well, with those numbers, you might say, well, this is quadratic formula, but there is a solution, but it's not incredibly obvious, and it's this. That'd obviously be an x here and an x here. 84, in fact, is 21 times 4. So I can put 21 here, 4 there. Let's work out the signs. This has got to generate negative 25, and they've both got to be negative to generate the plus 84 here. And if you do all the multiplications, you'll see that this is the factorization of the quadratic. So therefore, we can say that x is equal to 21, or x is equal to 4. Now that's where this statement in the question, it's the number of green balls, is greater than 4. So our answer must be that, therefore, the green balls must equal 21 balls. And that is your answer.